Good morning, all. So, as I'm getting called out to go attend interviews this morning, I decided to record your lesson. So, we are going to dip into 8.2, which is going to focus on arithmetic sequences. So, what that means is I'm going to add or subtract the same number every time for my sequence. So, for instance, maybe I would like to start with the number 2, and I want to subtract 3, and I go down to -1. I want to subtract 3 again, and I want to go down to -4. I want to subtract 3 again, I want to go down to -7. So this is an example of a sequence that is arithmetic. So one of the things that we needed to finish talking about from yesterday's notes, from section 8.1, is this crazy looking summation notation. So first of all, I want you to notice this is a sigma, and it stands for summation, and it means that they want you to plug in this first number, second number, third number, fourth number, fifth number, and then add them all together. So we are going to 2, 3, 4, 5. So we're going to take these three things and add them together. So plug in 1, 3 times 1, 3, 2, 3 times 2, 6, 3, 3 times 3, 9, 4, 3 times 4, 12, 5, 3 times 5, 15. Something crazy I would like for you to just notice this pattern. 3 and 15 add to 18, 6 and 12 add to 18 as well. And I just noticed that was kind of crazy. So 18 plus 18 plus 9, and our total is going to come to 45. So do me a favor. When we have class again next week, I would like to show you in your calculator how to type this in as well. Okay, so let's take a look at the next example. Remember, in videos, you can always pause it and write down. Okay, so this one, we are going to plug in the numbers 3, 4, 5, and 6 is where we stop. Okay, so I'm going to write this down. Plug in 3, 4, 5, 6. All right, here we go with 3. 3 squared 9 plus 1, 10. 4. 4 squared 16 plus 1, 17. 5. 5 squared 25 plus 1, 26. 6. 6 squared 36 plus 1 is 37. All right, so if we add those all together, we get out to a total of 90. So again, this is just a nice shortened notation for us to say, find the sum of the first 5 terms, find the sum of the terms 3 through 6. All right, moving on. We are now going to talk about arithmetic sequences. Okay, so I'm going to use the language of arithmetic sequences. AN equals D times N plus A sub 0. That's better. Okay, but I would also like for you to note that is exactly the same as MX plus B. Okay, so our growth is our slope. D stands for common difference. D stands for common difference, and you can also think about it as slope or growth. N is what we plug into, and the 0th term, and your y-intercept is 0 and whatever that is. Okay, so the first thing I would like for us to do is I would like for us to write down the first 5 terms. So here we go, our first term is 2. And I think I meant to write down D right here instead of C. I better work on my alphabet. Okay, so the common difference is 3, and that's a positive 3. So 2 plus 3 gets us to 5, and I'm going to keep adding 3. Okay, so 5 plus 3 is 8, and 8 plus 3 is 11. Okay, I'm going to stop right there because I ran out of room. So there are the first 4 terms. And the next thing I'm going to do is I'm going to work on the rule. Okay, so I'm growing by 3. So 3 times n plus 0th term. Some of you will just go backwards. 11, 8, 5, 2, take away 3, and we get to negative 1. That purple's almost done, isn't it? And I'm just going to double check it. I'm going to plug in, let's plug in 2, and hopefully we get out 5. 3 times 2 is 6. Take away 1 is 5. All right, this one I've already written down the rule. So a lot of you will be able to go forward and you'll be able to tell me that it's plus 4. If you're ever not sure, you can subtract your terms. So 11 take away 7. You can always go backwards and we will get out 4. So the common difference is 4. So here's our rule. We're growing by 4 plus, if we go backwards 1 term, we get out 3. Okay, last goal of today. We are going to work on finding the sum of an arithmetic sequence. And the formula is right here. S, big S for sum, number of terms you want to find it for, first term to the last term, and then divide it by 2. This actually has a super crazy story, and it has to do with Gauss. And if that name sounds familiar, that's because we just talked about him in the matrices with the Gaussian-Jordan method, if that sounds familiar. So remind me when I get back on Tuesday, and we'll have a math history story of how little Gauss, when he was like 8, came up with this formula. It's actually pretty cool. Okay, so I would like to find the sum of the first 150 terms. I could also have worded it as find the partial sum of up to 150 terms. And so right here, I left a series. So the first thing that you are going to do is that you are going to find the rule. And so I'm noticing that we are increasing by 11. So my rule is going to be growing by 11. And if I go backwards 11, we get out 5 minus 11, negative 6. Okay, secondly, I would like the first 150 terms, so I better figure out what A of 150 is. So we're going to plug in 150. And we get out, whoa, 1,644. Getting large here. Okay, and then the third thing is that they wanted the sum of the first 150 terms. So according to the formula, we're doing 150 terms. The first term was 5. The 150th term was 1,644. And then we divide it by 2. Okay, and I'm just going to type that straight in to the calculator. And that way, we don't have to sit there and write out 150 times because, frankly, that would be lame. All right? So, we have this nice formula. It does only work for sequences that are adding or subtracting something. Okay, so I'm going to write down this 1, 2, 3, 6, 7, 5. So that being said, why could we potentially use this into the future? A lot of times theaters, I'm going to use smaller numbers just to make sense here, but they have less seats in the first row, and then it starts to grow. More seats, more seats, more seats.
Good morning.
As it starts to grow out. So therefore, when they want to figure out the total number and say 150 rows in this huge theater, they can use this nice formula right here. All right, your goal today is to finish and turn in 8.1 and 8.2 on the same page. I'll see you guys on Tuesday.